The workshop smelled of copper and sawdust, heavy with the scent of sweat and nerves. I could still hear Harris's words from yesterday echoing in my head. If you are lazy with green wires and clamps, every other lesson dies with them. That was the last trial, the battle against stray current. Today, a new trial waited for us, the mysterious art of splicing and terminations. I stood before a cluttered workbench. A half-open junction box sat there like a puzzle box from another world, wires spilling out in tangled coils. Red, black, white, and bare copper, twisted like restless serpents. My palms were slick with sweat. Harris walked in, his boots striking the floor like a gavel calling court to order. He carried only a wire stripper in his hand, but in his grip it looked more like a sword of judgment. Harris, splicing and terminations may look simple, but do them wrong and you invite fire, failure, and disgrace. Splice is not just about joining wires. It is about safety, durability, and code compliance. His voice struck the room like thunder. No one dared laugh. I swallowed hard, staring at the wires. They looked harmless, but his words made them feel like vipers ready to strike. John, I've seen workers twist wires together and wrap them with electrical tape. That's what I saw back when I was just helping on side jobs. Is that allowed? Harris's eyes narrowed. Harris, absolutely not. That is outdated and dangerous. The NEC does not allow such shortcuts. We use proper connectors, wire nuts, pushing connectors, or crimps. Anything less is gambling with fire. Maria, standing to my right, raised her hand. Maria, how much insulation do we strip before we splice? Harris, about half an inch. It's too short and the connector will not grip. Too long and bare copper sticks out. That is not just sloppy, it is a safety hazard waiting to strike. Kevin, bold as ever, stepped up to try. He stripped a wire, but nicked the strands. Harris's voice cut through the room. Harris, stop. That wire is now weak. Damaged conductors generate heat under load. Nicked strands are not just cosmetic flaws. They are failure points. Remember this. Every strand carries current. Break one, and the others suffer. He tossed the ruined piece into the trash. The sound was final, like a bell tolling for the dead. Harris then laid out a series of connectors on the table. Wire nuts in bright colors, push-in connectors that clicked like tiny traps, crimp sleeves of shining metal. Harris, each connector has a rating, gauge number of conductors, material compatibility. You do not cram 5 wires into a nut rated 4-3. And when connecting devices, you use pigtails. Maria tilted her head. Maria, why pigtails? Harris, because they reduce stress on the terminal lugs and make replacements easier. A device should not carry the burden of multiple splices. Pigtails give flexibility and safety. Motion to the junction box. Harris. And remember this, every splice belongs inside a junction box with a protective cover. Loose or exposed splices are direct fire hazards. The words struck me like an incantation. Splice inside the box, cover it, protect it. Foreman entered at that moment. His eyes scanned the workbench like a hawk hunting prey. Foreman, splices outside the box. It's not just a mistake. It's a violation. A crime against safety. He pointed at me. Foreman, apprentice, answer me. What happens if you leave a splice hanging in the open? My mouth went dry, but I forced the answer out. John, loose or exposed splices lead to arcing, overheating, and fire. The foreman's face softened slightly. Foreman, good. Remember that answer, because someday your inspector will ask the same. Harris then set up the first round of tests. Harris, strip this conductor. Half an inch? No more, no less. Clean, without nicking. I took the wire stripper, hands trembling. The steel jaws glinted under the light. Slowly, I squeezed, rotated, and pulled. The insulation slid off, leaving copper shining clean and whole. Harris tugged the wire. It held strong. He gave a single nod. Harris, correct. Now, what tool is used to strip insulation? John, wire stripper. Harris, good. And what happens if strands are nicked? John, the wire weakens. Heat builds under load. Fire risk. Harris. Excellent. Kevin stepped forward for his second attempt. This time he stripped too much insulation, leaving a long, naked section of copper. Harris's too much exposure leads to shock hazards. Bare copper is not courage, it is carelessness. Cut it again. Kevin's face burned red as he fixed his mistake. The class chuckled softly, but I didn't. I knew that could have been me. Harris pulled out a handful of aluminum wire. His eyes gleamed. Harris, this will be tomorrow's lesson. Aluminum is different. It oxidizes, builds resistance, and demands compound. But today, we master the basics. We spent the next hour practicing splices. Wire nuts twisted like little helmets over pairs of copper. Push-in connectors clicked as we pressed stranded wire inside. Crimps flattened under pliers, holding tight. Harris circled like a hawk, testing every joint with a tug. Maria's splice was neat. Wires twisted firmly before the cap. Harris tugged and it held. Harris, good. That is how you earn trust. Always test, always confirm. He stopped at my work. I had capped 2 wires with a nut, but hadn't twisted them tightly enough before capping. He pulled on, 1 wire slipped free. My stomach dropped. Harris, failure. You must twist firmly before capping. The nut is not magic. It cannot fix laziness. The foreman stepped forward again. Foreman, tomorrow we test torque. It's tight enough to hold, not enough to crush. Some of you will pass, some will not. If you fail, you go home. His words fell like a hammer. I clenched my fists. I had failed once already. I would not fail again. That night in my notebook, I wrote down the sacred rules. Strip cleanly, correct length, use proper connectors. Twist firmly before capping. Every splice must be boxed and covered. Loose connections are death. As I closed the notebook, I felt something new burning in my chest. Splicing was no longer just a technical skill. It was a trial, a test of worth. Each connection was a promise between electrician, inspector, and every family who would one day live under those wires. Tomorrow, aluminum and fire would test us further. Yesterday, I faced my first splice. I learned that tape was never enough, that connectors must match the gauge, and that every joint must be hidden safely inside a junction box. I survived, but barely. The foreman's words still rang in my ears. Tomorrow, you will face torque. If you fail, you go home. Morning came, and the workbench was set like an altar of judgment. 2 wires lay across it. 1 copper, bright and red with strength. 1 aluminum, pale and dull, like a blade left too long in the rain. Harris stood before us, his eyes sharp. Harris, copper is strong, but aluminum is treacherous. It oxidizes quickly. Oxidation builds resistance. Resistance builds heat, and heat will burn down everything you thought was safe. Tell me what must be applied to aluminum splices. The room was silent. Then I raised my voice. John, antioxidant compound. Harris nodded slowly. Harris, correct. Without it, aluminum becomes a slow fire starter. Remember, this aluminum looks harmless, but it hides a hunger for destruction. He spread a dark paste across the stripped end of the aluminum conductor. The class leaned in. Compound coated the surface, sealing it from air, like a protective charm against corrosion. Maria asked her question softly. Maria, why do we use pigtails, Harris? Harris, to reduce stress on terminal lugs and make replacements easier. Devices must not carry the weight of multiple splices. With pigtails, you protect the device and the system. Kevin, impatient, stepped forward. His pride burned hotter than caution. Kevin, I don't need paste. I don't need pigtails. Watch this. He stripped the wire roughly, jammed it into a nut, twisted hard, and smiled at us with false victory. A faint spark jumped, sizzling in the air. The class gasped. Harris's voice was sharp as a whip. Harris, loose connections lead to fire. Faster does not mean safer. The smell of scorched insulation lingered in the room. Kevin's grin faltered. Harris, answer me, why must connectors match the gauge of the conductor? John, because grip and current capacity depend on it. If the gauge is wrong, the connection loosens, heat builds, and fire follows. Harris, good. Now show me how it is truly done. My hands trembled as I reached for the aluminum wire. I stripped the insulation slowly, exactly 1/2 inch. No more, no less. I coated the end with antioxidant compound, dark and thick. I twisted it firmly with another wire, capped it with a rated wire nut, slid a piece of heat shrink over the joint and sealed it. Harris tugged the splice. It held. His eyes glimmered, just for a second. Harris, excellent. Always test. If one wire slips, you have failed. Maria followed, making her own neat splice. She twisted carefully, capped, and sealed. Harris tugged. It held firm. Maria. What happens if we tighten screws too much on aluminum? Harris. Over-tightening crushes the conductor. The strands weaken. The joint overheats. Torque is balanced tight, enough to secure, not enough to destroy. Tomorrow, you will face this trial. The foreman entered, boots echoing against the concrete. He scanned the workbench, eyes cold. Foreman, answer me, apprentice.
Why must we never mix copper and aluminum directly?
I spoke, voice steady.
John, because their metals react differently.
Without dual-rated connectors, mixing copper and aluminum builds corrosion, loosens the joint, and causes failure. Foreman. Correct. If I find a single joint mix wrong in your work, you will fail. The tension in the room thickened like smoke. I felt sweat on my neck, but inside something burned brighter. For the first time, I felt like I was not just surviving the lesson. I was mastering it. We practiced until our hands ached. Crimps squeezed under pliers, holding wires tight. Pigtails branched like rivers, relieving stress on terminals. Heat shrink tightened under flame, forming protective skins. Every move felt like a ritual, a spell to keep chaos away. Kevin tried again. He stripped too short this time, leaving not enough copper for the nut to grip. Harris pulled, and the wire slipped out instantly. The class laughed softly. Kevin's face flushed, his pride cracking like brittle glass. Harris too short, and the connector fails. Too long and copper shows. Too loose and heat builds. Too tight and the conductor dies. Remember these 4 laws, apprentices? He turned to me. Harris, tell me, John, after applying a wire nut, what must you always do, John? Tug to test. Harris, correct. Without the test, you gamble with lives. I nodded, my chest swelling with something more than relief. Pride, maybe, or the first hint of belonging. As the day closed, Harris gave us one last warning. Harris, tomorrow comes the torque of destiny. Tighten until secure, but never crush. Precision, not brute force. Some of you will rise, some will fail. The foreman added his final decree. Foreman, fail tomorrow, and your apprenticeship ends. The workshop fell silent. The only sound was the hum of fluorescent lights and the beating of my heart. I closed my notebook and wrote the sacred rules of aluminum. Aluminum oxidizes isolate with compound. Never mix metals without dual-rated connectors. Pigtails protect devices and lugs. Twist firmly, cap correctly, seal completely. Always test, always confirm. As I finished writing, I felt a strange energy. It was more than electricity. It was the fire of transformation. Tomorrow, the torque of destiny would decide who walked forward and who was cast aside. Morning came with a cold brightness that made the shop feel like a temple before a ceremony. On the bench lay terminals, lugs, a terminal block, a torque screwdriver, and a continuity tester waiting like judges. Yesterday, aluminum taught us about oxidation and patience. Today we would learn whether our hands could hold a line between strength and ruin. Harris stood at the panel mock-up and tapped a binding head screw lightly with the driver. Harris, a connection is a promise. It's tight enough to keep it, not so tight that you break it. That is torque. A secure connection lives in that narrow space. Fail it and heat will speak louder than you. He pointed to a tray. Harris, stranded wire, solid wire. Tell me the difference and tell me why it matters when you land them, Maria. Stranded is flexible and spreads under pressure. Solid holds shape. Stranded needs the right terminal or ferrule to keep the strands together. Solid can deform if crushed. Harris nodded. Harris, and you land both beneath the head where the screw pulls metal to metal. No whiskers of copper straying beyond. No broken strands. No crushed cores. Code compliance is not a rumor. It is a requirement. The foreman rolled in a cart with 2 junction boxes. One was neatly arranged, each conductor trimmed to an identical strip length with color coding honored and a protective cover sitting aside. The other box was a tangle of ambition and shame. Foreman, 2 boxes. One passes inspection. One cooks in silence. You will tell me which is which, and then you will prove it with your hands. Harris opened the tidy box and pointed with the driver. Harris. Hot conductors, black and red, neutral white. Equipment grounding conductor, green or bare. Labeling and identification must survive time. Use tags where the service demands it. Use ink that does not lie when the panel warms. Color coding is a language. Speak it cleanly. He lifted the mess. Harris, what is wrong with this picture? Kevin stared at the knot of wire nuts, push-in, connectors, and tape. Kevin, too many conductors under one wire nut. Wrong gauge in a connector not rated for it. A strain relief on the cable entry. And I think that splice lives outside the box once the cover goes on. Harris, good eyes on strain relief. The cable is pulled, the clamp carries the force, not the splices. If you forget strain relief, the first yank turns your work into a trap. Also note box fill. The code gives you a volume limit based on conductor count and device size. Overfill and heat and abrasion do their slow work. You do not cram. You calculate. You choose the right box before the first cut. He laid 3 cards on the table. Ground splice, neutral splice. Harris, build me each. Ground together your equipment grounds. Keep neutrals loyal and continuous. Tie multiple hots as required by the circuit design. But remember, handle ties and 2 pole breakers where a shared neutral demands it. The point is not speed. The point is clarity, and a tight joint that will not loosen when winter shakes the metal. Compression connector here. A rated twist on connector here. Crimp where the listing demands crimp. Solder is not your savior. If you use solder at all, it must live inside a proper enclosure, and only after you have a mechanical joint that holds cold. Heat alone is a liar. Tapped a terminal block mounted on a plate. Harris, land these conductors on the terminal block as the manufacturer intends. Use the correct strip length. Bring the copper in straight. Do not fan out strands. Tighten to spec, and continuity test from point to point and prove your path. If the tester is quiet, you fix the silence before anyone else hears it as smoke. We began. My first task was a neutral splice. I stripped exactly 1/2 inch and checked the clean copper for scars. I brought 2 whites together, then a third for the pigtail to the device. Twist firm cap with a connector listed for the gauge and count. Tug each conductor. Nothing moved. I labeled the pigtail and tucked the joint carefully to the back of the box. Maria worked a ground splice. She gathered bare and green conductors, added a short pigtail to the yoke screw location, and used a green listed wire nut with a hole for the pigtail tail. She pulled each wire like a truth test. Nothing slipped. She slid heat shrink over an exposed sleeve and warmed it until it hugged the joint like armor. Harris nodded once. Kevin tackled a multi-wire splice with 2 hots and a feed-through. He paused at the connector chart, then swapped the small nut for the correct size. Kevin, gauge, and count must match the listing. Wrong size means a loose connection or crushed conductor. Harris. Say it again so your hands remember. Harris walked behind us like a patient storm. Harris. What produces an arc fault? A loose joint? A damaged conductor. A poor termination that lets metal jump the small air between it and what it wants. An arc is a knife that keeps cutting, but produces a short circuit, a direct, unwanted path between conductors. Both can start with your laziness. One whispers, one shouts. Fault current is the cry that trips a breaker. Your job is to give that current a fast path home, so it clears the fault before heat turns wood into memory. He raised a question like a gavel. Harris, after you cap a splice, what must you do? Class. Tug to test, Harris. Where must every splice live? Class. Inside a junction box with a cover. Harris. What is box fill? John. The safe capacity of conductors and devices that a box can hold. We landed conductors under binding head screws at the devices. I felt the old habit rise in my wrist to lean on the driver and crush the copper. I stopped. I set the torque driver and tightened to firm. The conductor did not flatten. It did not pull when I tugged. It simply stayed, a quiet yes. Harris. Inspectors carry torque tools, so should pride. Over-tightening is not strength. It is the beginning of failure. Loose is not kindness. It is heat you have not met yet. The foreman pointed to a cable entering a steel box without a clamp. Foreman, show me strain relief. I installed a compression connector at the knockout, slid the cable through, set the jacket under the clamp, tightened until it held without crushing, and checked that the bare and bonded parts stayed where they belonged. He grunted the small approval that felt better than applause. Harris handed me a device with both copper and aluminum conductors approaching. Harris, you already learned aluminum. Do not mix metals unless the connector is rated for both. If you must join them, you use the dual-rated device. The correct antioxidant compound on the aluminum and torque like a clockmaker, not a blacksmith. I built the joint in a separate box with a dual-rated connector, sealed the aluminum with compound, tied the copper, and labeled the splice can location so the next electrician would not have to guess. Harris tested continuity, then gave a small smile. He dimmed the lights and brought the class to the bench with the ugly box. He pointed at the rat nest of connectors and tape and asked his quiet questions. Harris, what happens here under load? Maria, overheating. The wrong connectors loosen. The insulation bakes. The voltage drop rises across bad joints. Arcing begins, and the damage becomes its own fuel. Harris, cure it. We cut back to clean copper, stripped correct length, rebuilt splices with listed connectors, sorted grounds together and neutrals together, separated hots by circuit, and tied where design required. We added a proper strain relief. We counted conductors, calculated box fill, and upsized the box, because numbers did not care about pride. We labeled circuits and destinations. We landed a protective cover and logged the work in a small book. Because memory is not documentation, quiz came like rain after heat. What does a continuity test check, John? A proper electrical path. Harris, why are neat splices important? Maria, easier to inspect and safer in service. Harris, which metal do you most commonly splice in general branch circuits? Kevin, copper. What causes nuisance trips and hidden danger when you land multiple wires under one screw not rated for it? John, a loose connection heating in parallel paths where they do not belong. He set up a fault simulator. A small switch could place a metal tab against a hot terminal by surprise. Harris, show me that your bond and your splice will make the breaker see the emergency. I armed a test plug at a GFCI on the mock circuit we had just built. Harris threw the tab. The GFCI tripped fast. The breaker behind it stayed calm. The path to ground had done its work. He reset. He moved the fault to neutral. The breaker cleared like a guard dog finally hearing the right sound. The room exhaled. The foreman checked our boxes for covers and screws torqued. He wiggled devices to see if the strain relief truly relieved. He pulled on a pigtail and watched the yoke stay calm because the splice did not depend on the device to carry the burden. He looked at me longer than the others. Foreman, you crushed a conductor yesterday, John. I did. Foreman. You did not crush one today, John. I did not. He set a small stamp on my glove. It was not ceremony. It was work turning into trust. Harris gathered us for closing. Harris's proper installation is not fashion. It is a chain of choices that keeps families safe. Splice inside a box. Use the right connector for the gauge and count. Do not mix metals without the correct device. Control torque. Provide strain relief. Label and identify so the next person can read the story you leave. Code is not a ceiling. It is the floor. You'll stand on it or you fall. I looked at the boxes we had built. The tidy one looked quiet, almost plain. But inside every tight joint and clear label, there was a discipline I could feel in my hands. I understood now what a splice really was. Not just wires together. A bond between my promise and the lives that would trust it. Harris killed the power and handed me the continuity tester. Harris, put this in your pocket. Tomorrow, the inspector comes. Every splice will be judged. Every label must make sense. Every cover must sit home. If you have not made friends with truth by then, truth will not make friends with you. I slipped the tester into my pocket and felt its weight like a small oath. The shop grew quiet. Somewhere outside a forklift called and answered. I closed the last box and watched the protective cover settle flat. The screws snug, but not cruel. The circuit felt like a heartbeat under my fingers. Tomorrow, the gate would open to inspection, and there would be no fog to hide in. We would speak in copper and steel and ink, and the work would answer for us.